right, ladies and gentlemen. Can ChatGPT earn its wings? Well, first of all, I just want to make sure that we are all on the same page here. Saab is no longer in automotive business. Today, Saab is a global defense and security company, delivering products, services, and solutions from military defense to civil security. And we do this in 5 core technology areas. Now, these are underwater systems, fighter systems, command and control sensors, and advanced weapon systems. Now, I work as a systems engineer at Saab Dynamics, and I work primarily with underwater systems. However, at Saab, with technologies such as AI and autonomy, we work across domains and across business areas, so I also contribute to future combat air systems. I do this in a project called Mission Autonomy, and on this next slide I want to introduce this project to give you the context for the rest of the presentation. So Mission Autonomy is really all about finding ways for non-human entities to contribute in the domain of tactical reasoning and decision-making. Now, AI can potentially contribute both as decision support in manned platforms and also as decision-making in unmanned platforms. Now, this is driven, these efforts are driven by a belief that the future operating environment will be increasingly complex and also fast-paced. So, in this future, AI functionality will not only be nice to have, it will actually be need to have, because we need this to parse and interpret our environment to maintain situation awareness. An additional question which we aim to address is the problem of how to scale control of autonomous systems. Now, one approach is to extend mission command, which is a human-to-human control mechanism, to also include autonomous systems. What we aim to do then is to, instead of micromanage someone or something, we want to give them tasks or assign missions which they perform autonomously. This, of course, requires quite a high level of intelligence, be that artificial or otherwise, but that is the aim. So last fall, when we were working on this, trying to elevate the cognitive capabilities, so to speak, of our systems, something happened. ChatGPT was released by OpenAI. Now, as I will discuss in this presentation, OpenAI did not solve all of our problems, but they did make us, and the rest of the world really, reconsider a lot of aspects of AI, and also to adjust a lot of our timelines. Questions which seemed purely academic or even philosophical just a couple of years ago are now very practical and even quite urgent. I will mention, though, that nothing I say or what I say here is not specifically tied to ChatGPT, but large language models, or LLMs, more broadly. And I would argue that LLMs are quickly becoming the de facto standard method for achieving general machine intelligence. And the avalanche of funding being poured into this is really going to cement this, I believe, in the near future. So something happened, but more will come. ChatGPT is not the peak or the end. This is Demis Hassabis, CEO of Google DeepMind, in a recent interview saying that at a high level you can think of Gemini as combining some of the strengths of AlphaGo type systems with the amazing language capabilities of large models. Now, Gemini is Google's upcoming answer to ChatGPT, and the AlphaGo type systems are these deep reinforcement learning systems that made DeepMind so famous a few years back. So, what Hassab is really saying here is that, or is hinting at, that they will be able to bring the tactical prowess, if you will, of these systems and combine these with ChatGPT-like functionalities. And if I can remind you of the goal of Mission Autonomy Project to have AI contribute in the domain of tactical reasoning, this is a huge and important step in that direction. And it's happening right now, this fall. So, considering this then, considering this progress, and if we assume that the progress will continue, which we have every right to do, I believe, a likely future scenario will be one wherein there are generative models out there in the world with tactical reasoning capabilities really on par with humans, and these will scale with compute, which is very important. In addition, however, they are also interactive, as ChatGPT is now. You can ask it questions, and it can ask you questions back, really. And they are adaptive with respect to their environment and their missions. So two questions to ask ourselves then is first, how do we gain access to this during missions? And also, if we get access, how do we utilize it? What do we want to use it for? So companies like the ones I mentioned, OpenAI and DeepMind, they are raising the bar for what is possible, and we want access to the same fundamental capabilities in some sense. But we, working with real-time systems and working in the military domain, have very different use cases and also very different considerations. So I will address these unique considerations looking at three concepts: connectivity, latency, and also suitability. So first up, connectivity. First, I want to make a note about ChatGPT again. Just let us appreciate that for the absolute miracle of IT infrastructure that it actually is. So we as consumers, we use ChatGPT through our apps or in our phones or on our laptops, and some dozen GPUs somewhere in Europe start spinning, and just seamlessly you get your answer in seconds. And this is really amazing. But do we want to emulate this and emulate this achievement really in the military domain? Could we, for example, just assume connectivity and make API calls from the cockpit, for example? Well, we likely do not want to go this route because the future operating environment is expected to be highly contested, especially in the electromagnetic spectrum. So this is one unique consideration. Now, given this, we have really two options. Either we can accept this and say that, you know, LLM access is a nice-to-have feature, and we leave it at that. If we have connectivity, we can do this. Alternatively, we can say we do not accept this. LLMs are need to have in this future environment, and therefore we need to bring the models and we need to bring the compute on board with us. Exploring the latter option then, let's talk about whether or not we can do this, whether we can bring the compute on board. So, we could probably pay for the hardware, we could probably cool it and power it in an aircraft. Now, volume and mass are always associated with trade-offs and opportunity costs. And I can't show you the internals of any specific aircraft here today, unfortunately, but I can assure you that they are quite packed. And so if we do not make room for more compute, there will be no room for more compute. And the trade-offs are important because it's hard to argue for removing something, because there's always a benefit, for example, to have more fuel, get more range. So we need to figure out what we want to do with the compute to raise the capability through intelligence to justify removing some fuel, for example. So a question then to ask is, how can we make the intelligence, the AI capability, so valuable, so indispensable that we can consider compute a first-class resource just like fuel? Latency. So earlier I talked about the pace of operations increasing, and this means that even high-level reasoning has tighter and tighter time constraints. Well, these large language models are very large, and so even though they operate at machine speeds, the inference can be quite slow. And then there's this trade-off then between the capability, the cognitive capability of the system and the speed of its inference. And both are, of course, related to the size. So we might want to strike a different balance depending on the situation. So if we have a lot of time to think in a scenario, we might want to think deeply. In another situation, we might prefer an answer that is good enough to one that is too late, right? And humans are great at this cognitive flexibility. We can adapt in this way. And AI has to be able to do so as well. So I have modulation here on the slide. Whatever system is responsible for modulating or choosing between these modes must also be able to understand its environment, and it is also subject to the very same time constraints. So at what level of abstraction, really, is AI most suitably deployed? Another way to ask this is to ask, what do we want the AI to think about? And of course, it's a very difficult question, but a good guide as a first approximation is whatever the human is thinking about in some sense. And now the human is not thinking about rudder actuation, how to actuate the rudders on the aircraft. And we do not want the slow and non-deterministic language models to do so either. So it is very important to figure out exactly which questions or problems we want the LLM to address and which are off limits. Now, if we can answer the question before it arises, we probably should. If we consider the more narrow case of landing an aircraft, say, there are autopilots today that manage this quite well. And an autopilot works because we have very good narrow mathematical models of air and of wings and of runways. But what if we can't answer the question beforehand? If we don't even know which questions will arise, then we need something that is very adaptive and is very resilient, just like humans are. So, in the limit, I suspect there will be nothing that a human does in the cockpit that an AI could not do equally well or even better. And at that point in the future, it might be fair to say that the AI has indeed earned its wings. So I want to leave you with a couple of questions. The first one being, are LLMs in this context nice to have, or are they need to have? Another way to phrase it maybe is, what would it take to take them from nice to have to need to have in the future? And secondly, what does this mean for real-time systems, such as an aircraft? And how can we make room for these things in an already complex and in a very complex system? And we hope to address these questions, and maybe some of you will join us in doing so. All right. That was all for me. Thank you so much.